Hey everyone, and welcome! Today, we are going to dive deep into one of the most fundamental and honestly most powerful tools in any programmer's kit, the C++ string. We're going to pull back the curtain and see how text really works. So, let's get into it. But first, just think about this for a second. That app you open every morning, that game you're totally hooked on, or your go-to website. Every single piece of text you see, your username, the messages, the search results, it's all being managed by something just like a C++ string. They are literally the backbone of how we talk to our digital world. So to really get how all that magic happens, we gotta start with the absolute basics. What in the world is a C++ string anyway? At its core, it's actually super simple. A string is just a sequence of characters in a specific order. Picture taking individual letters, numbers, and symbols and literally stringing them together on a thread. That's it. That's your string. And this right here really shows you how far we've come. See, back in the day, we had these C-style strings. They were basically just raw character arrays. And let me tell you, they were a real headache. You had to manage all the memory yourself, which was a classic way to introduce bugs and even serious security holes. The modern C++ string, though, it's a whole different beast. It's a smart object packed with built-in tools and, best of all, it handles its own memory. For a programmer, that's a massive, massive upgrade. Okay, so now that we know what a string is, let's pop the hood and take a look at its anatomy. How is this thing actually built? All right, this right here, this is probably the most crucial thing to remember. Every single character inside a string has its own little address, and we call that an index. And in C++, just like in most programming languages, we always start counting from 0, not 1. So the very first character is at index 0, the second one is at index 1, and so on. Get that down, and you're halfway there. And this is how we put those indexes to work. C++ gives us a few different ways to pinpoint a single character. You can use .at, which is the safe route. It'll check to make sure the index you asked for actually exists. Or you can use the square brackets. This way is faster, but it's a bit more living on the edge. It won't warn you if you go out of bounds. And then you've got these handy shortcuts, .front and .back, to instantly grab the characters at the very beginning and the very end. And this is where the real fun begins. See, a C++ string isn't just a boring old box for text. No way. It's a complete toolkit for twisting, turning, and transforming text. So let's open that toolkit up and see what we've got. First up, the basics. You gotta know what you're working with, right? How big is this string? For that, you've got two tools that do the exact same thing, .length and .size. They both just tell you the number of characters. And if you just need a quick yes or no answer, .empty gives you a simple true or false. Is there anything in here? Nope? Okay, great. Now, strings are meant to be changed. They're dynamic. And your toolkit is ready. Want to shove some text right in the middle? Use .insert. Need to chop a piece out? .erase is your friend. Tacking something onto the end is super common, so you can use .append or just the simple plus equals operator. And if you want to do a complete swap out, .replace lets you target one section and drop in something totally new. I love this quote from the source material because it perfectly sets up our next set of tools. What good is having all this text if you can't find that one little piece you're looking for? The find method is your bloodhound. You give it a smaller string, what we call a substring, and it'll sniff through your main string from the start to find the first time it appears. Our find does the same thing, but it starts from the end and works its way backward. Now, here's the really important part. What happens if it doesn't find anything? Your program doesn't crash. Instead, you get back this special value called string/npause. So if you see npause, that's just the signal that the needle wasn't in the haystack. Okay, theory is great, but let's get our hands dirty. We've seen all the tools in the toolkit. Now let's put them to work and solve a real-world problem. This is where it all clicks. So here's the plan. We're going to build a simple password strength checker, a perfect little project that uses pretty much everything we've just talked about. Let's use PS-word1 as our test case. Is it strong? Does it meet our rules? Let's find out together. So here's our game plan. First, the easy one. Is it at least 8 characters long? We'll use .length for that. Check. Then, for the other rules, we'll use .find. We can ask it, can you find any character from the entire lowercase alphabet in our password? Yep. Great. Okay, now can you find any character from the uppercase alphabet? How about any number? And finally, can you find any symbol from our approved list? If it passes all those checks, we're in business. And the results are in. Our password? Password 1. Nailed every single test. It's long enough, it's got an uppercase, a lowercase, a number, and a symbol. Look at that, a perfect score, 5 out of 5. So the final verdict is excellent strength. And just think about that. By combining just a couple of simple string tools, length and find, we built a genuinely useful and practical little program. That's the power of this toolkit right there. So we've covered the what, the why, and the how of C++ strings. We've looked at all the tools in the box, and we've even put them into action. Now we get to the final and honestly the most important part, which is all about you. You now have the fundamental toolkit for working with text in one of the most powerful languages out there. I mean, think about it. From analyzing huge amounts of data, to building immersive games, to creating the next killer app, it all starts with handling strings. So the only real question left is, what are you going to build first?